Hey guys, welcome to EduKaji. If you guys are first time here, allow me to introduce myself. So my name is Walter and I'm a chemistry tutor as well as a real life scientist. So this particular video will be discussing about a past trial paper for the SPM Chemistry syllabus. So without further ado, let's jump right into it. Right, so this is the Perak state trial paper for year 2022. This is the first set, paper 1. So without further ado, let's take a look at the questions together. So the first question here is, who discovered neutrons? So the simple answer here will definitely be C, which is James Chadwick. Okay. And number 2, which of the following is used as which of the following is the use of phosphorus 32? So phosphorus 32 has a main function of determining the amount of fertilizer intake by plants. Okay, so because phosphorus is actually incorporated into fertilizers in the form of a phosphate, and because it's radioactive, it's able for scientists to trace back the amount of radioactive particles inside the plant. So the more fertilizers the plant intake, then of course the more radiation can be found in the plants. So therefore, I would say the answer for number 2 here will be to study the metabolism of the plant. So for number 2, the answer is donkey. For number 3, the relative molecular mass of M2SO43 is 342. Right, so what is the relative atomic mass of element M? So in this case, we've got to calculate and see what is the M2SO43. So we have 2M plus a total of 3 times 32 for sulfur. And then we have a total of 12 times 16 for oxygen, because we have a total of 16 oxygen over there. Okay, so let's take a look at this. And all of this must total up to 342. Okay. So if you use your calculator and check and see what is the number. So that'll be 2M plus 96 plus 192. So supposedly this one will be equivalent to 342. So 2M will be 342 minus 96 and minus 192. And then you get a total of 54. So 2M is equals to 54. M is equals to 54 divided by 2. So you get 27. So therefore, the answer here will be A. Let's look at number 4. The boiling point of chlorine is lower than bromine. Which statement best explains this phenomena? So the boiling point here of chlorine is lower than bromine. I think the main idea is very simple. Because going down group 17 in this sequence, so it basically goes down from fluorine onwards. So we have fluorine, followed by chlorine, then bromine, then iodine. So going down the group, right, the atomic size of the elements will increase. So if you talk about the size of the molecule, F2, Cl2, Br2, I2, the size of the molecule becomes bigger and bigger, okay, because the atomic size increases. So of course, definitely I would say that the molecular size will be increased. So when the molecule becomes larger, right, the van der Waals forces between the particles will increase in strength. So that means that the intermolecular force will be stronger between the molecules as the size of the molecules increases. So the best way to explain why chlorine has a lower bromine than, has a lower boiling point than bromine is because the intermolecular forces or the force of attraction between the chlorine molecule is much weaker. So therefore, the answer here would be donkey. Number 5, element P is located in the same group with iron in the periodic table elements. Which of the following are characteristics of P? So if it is located in the same group with the iron in the periodic table, then I would assume that P is actually transition element. And usually transition element has like certain unique properties. So I'll say that it can act as a catalyst, that's one of it. And it has more than one oxidation number, because these are the unique properties of transition elements that no other metals in the periodic table in group 1, group 2, they don't have all these properties. Okay, and definitely 1 and 2 is wrong, because as a metal in the transition element part, it must have a high melting and boiling point as well as a good heat conductor. So therefore, these 2 is actually wrong. So the only possible answer here will be donkey lah. All right, 3 and 4. Number 6, which of the following substances is a diprotic acid? Diprotic acid refers to an acid which can produce 2 moles of hydrogen ions per 1 mole of acid molecule. And I think only one of these can be the answer, which is sulfuric acid. If you see sulfuric acid, if it dissociates in water, it will produce 2 moles of H+, whereas the rest of it does not. So for ethanoic acid, it is supposed to be CH3COOH. Okay, if it dissociates in water, you will only get 1 mole of hydrogen ion per 1 mole of molecule, right? And then phosphoric acid will be H3PO4, so it's supposed to be a triprotic acid instead. So in this case here, you'll get 3H plus PO4, 3 minus. Okay, and then hydrochloric acid is only 1 mole per molecule. So there's only one possible one that can actually form double the amount of H+. So that's the answer is sulfuric acid. So let's move on to question number 7. All right, number 7, which of the following substances consists of ionic bond? So ionic bond is formed between ions, right? You must have ions, and usually it is formed from a metal and plus a non-metal. So among all of the substances in A, B, C, D, you only notice one which consists of a metal and non-metal. The answer is A, actually, calcium chloride, because calcium chloride is actually made up of calcium ions and the chloride ion. The rest of them are actually molecules. Okay, and molecules are usually non-metal plus non-metal, so they are covalent compounds or covalent bonding. So therefore, B, C, and D will definitely be wrong. Okay, so that's A for number 7. For number 8, diagram 1 shows the apparatus set up to prepare salt Y through reaction X. So this is referring to a diagram that shows you how to get, I'm not mistaken, it is actually a salt. So what is the reaction of X, substance A, substance B, and salt Y? So if you see properly, there is no precipitation in the picture. All right, probably whatever that's added. I think this is actually a precipitate. So if there is a precipitate being formed, because usually they will give you a more elaborated diagram, but this diagram is very simplified. All right, there's no heating involved. So if there's no heating involved and there's no rinsing of the substance, very hard to guess. But in this case, since there's no heating involved, then most likely there will be no crystallization. So if there's no crystallization in this picture, then I will guess most likely this is precipitation, which is technically double the composition to produce an insoluble salt. So in this case, then A and B will be out, because usually if it's a soluble salt, then there must be a heating process to make the solution more saturated. And then when you cool it down, you form crystals of the particular salt. But in this case, we don't see any heating process. So there's no heating process means shouldn't have crystallization process lah. So the only thing that makes sense is that the residue that's formed on the filter paper must be a type of insoluble salt that is created through precipitation. So therefore, it must be a double decomposition method lah. So it's going to be either C or D. But let's take a look and see what is the substance that is soluble and insoluble. The end product must be something which is insoluble lah, okay? Which means you have to look at the product, which means you have to look at this and this, because these are the products that's formed from the reaction itself. If you see the C, right, the product that is formed in C, you will notice that it is potassium sulfate. And if you recall back in your salts chapter, you will notice that potassium sulfate is soluble because all salts of sodium, potassium, and ammonium are all soluble. So this is probably not the answer already lah. Okay, remember that sodium, potassium, and ammonium salts are all soluble. So then we ask ourselves the second one. What about D then? Okay, D, barium sulfate is indeed insoluble. So I'll say most likely the answer is actually D. So if you add sodium sulfate and barium nitrate together, right, according to this equation, Na2SO4 plus BaNO3, you will get barium sulfate and sodium nitrate. So this one will create an insoluble precipitate, which can then be filtered off lah, which is what you see in the diagram lah. Okay, so imagine that this is actually one of it is sodium sulfate, and the other one is probably like barium nitrate. Then after a while, you will be able to see there is a precipitate being formed, and then after that, you can just filter them off, and then clean it with or just dry it with a piece of filter paper. You'll definitely be able to get the pure barium sulfate salt. So the answer is donkey. Number 9, diagram 2 shows the items which are made from a type of glass. I would say these are all very shiny and they are more suitable to be used as ornamental items with very high refractive index. So I think most likely this is lead crystal glass, right? Which we can buy from those shopping malls that sells a lot of crystal stuff. So that those are basically lead crystal glass. Okay, they're very shiny. They're very nice physical appearance. So number 9 here, most likely the answer is A. Okay, the rest of it is used in different functions lah. Okay, especially you see that borosilicate glass. So borosilicate glass is actually used mainly for heating, cooking, because they have a very high heat resistance. Even labwares, we use borosilicate glass. So that's the idea lah. Number 10, which of the following is a property of reinforced concrete? So reinforced concrete is concrete, but is added with other substances. So in this case here, I would say the answer for this question will be most likely resistant to corrosion. That's number 1, right? And a high compression and stretching strength. Why? Because these are two big properties or two great properties in construction, right? We normally use reinforced concrete to make high-rise buildings as well as houses. So those are the things that must be in place, all right? Those are the criteria that is suitable to make large buildings, which are very tall and very heavy. So one need to be more stable, right? The rest of it is not really an added advantage of creating those structures. So therefore, I'll say number 3 and number 4 is the best answer lah. So the answer is for donkey. That's the answer. Okay, number 11. What a reactive metal Y burned in air? What happened to the reactive metal Y? So if it burns in air, it means it must be able to react with the oxygen. Okay, so if that's the case, then it must be undergoing a what's it called? A combustion process. Okay, so if they can burn in air, means it can react with oxygen. If they react with oxygen, then of course they'll definitely gain the oxygen. So if it gains the oxygen, means it must be oxidation process. So referring to the choices that you have, right, which is A, B, C, and D, you have to look into one of the possible answer that indicates that it is actually an oxidation reaction. Okay, so we're referring to oxidation over here. Our main idea here is to focus on oxidation. So look at the 4 answers, then probably select one which can indicate it's an oxidation process. So let's look at A, decrease in oxidation number. Is it referring to oxidation? No. A decrease in oxidation number indicates that it is actually a reduction process. So that's not the answer that we want. Does it lose the oxygen? If it loses oxygen, then it will be also reduction. So it must not be oxidation. All right. Does it gain hydrogen then? Okay, if it's gain hydrogen, it's also reduction process. So that's definitely not an answer as well. So the only possible answer here will be for number 11 is donkey lah, because why? Loss of electrons actually indicate that it is oxidation process. So we're going to pick the answer lah. So usually what happens is that if you have metal Y, the Y will donate the electrons away to the oxygen. Why? Because oxygen is more electronegative, while the metal is usually more electropositive. So when they want to react with another substance, they usually donate the electrons away. So the best answer for number 11 here will be donkey. 12. Which of the following is correct? So electrolyte and non-electrolyte. So usually electrolyte are substances that can conduct electricity. Okay, those are what we call as electrolyte, and non-electrolyte will be cannot conduct electricity lah. So it depends on what we have. So I would say over here, non-electrolyte can be A, B, and C. Okay, so this one memang correct because they cannot conduct electricity. Sodium hydroxide inside got ions, so it can conduct electricity. So D is definitely out. But among all these 3, you have to look for something. A, B, C is the only choice that you have left. But you have to choose something that can conduct electricity lah. Acetamide cannot and glucose cannot. Why? Because they are made of simple molecules. Simple molecules got no charged particles to carry electricity. So the only answer here will be left with C lor. Okay, magnesium nitrate. Why? Magnesium nitrate is made up of magnesium ion and also nitrate ion. So ions are charged particles which can conduct electricity, while the glucose solution here cannot, right? So therefore, it matches electrolyte versus non-electrolyte. So the answer here will be C for number 12. 13. Mr. Hassan is the owner of a factory that produces sealants. Diagram 3 shows the characteristics of sealants that Mr. Hassan wants to manufacture. Resistant to organic solvent and resistant to oil. So something that cannot dissolve in organic solvent lah, I would say. Okay, so which of the following synthetic fiber is most suitable to be used to produce the sealant? It must be something that cannot react with any organic solvent, right? So sort of like a chemical resistant substance lah. Okay, so I think in this case here will be the best answer will be thiocol, because thiocol is something that cannot dissolve in organic solvents. For example, like methylbenzene or hexane and things like that. And it's also resistant to oil. The rest of it cannot. Okay, the rest of it technically to a certain extent can dissolve in organic solvents. So therefore B, C, D is out. So 13 is A. 14. The discovery of graphene has opened a new chapter in the field of nanotech. Various existing applications can be improved or replaced with graphene that has superior and distinctive characteristics. So which of the following is correct about the physical properties of graphene? If you don't know what graphene is, you have to remember how graphite looks like. So usually, right, last time graphite, if you notice, the carbon atoms in graphite are somewhat bonded covalently in a hexagonal ring shape. But you also remember that inside the graphite structure, there is actually layers in between them that's held together by weak van der Waals forces. So this is just to show you how it looks like. So just imagine you have two layers inside the graphite structure. So the layers of graphite is actually held together by weak van der Waals forces lah. You can see them in the dotted lines. So that is the van der Waals forces. So the graphite has many layers, which makes it very slippery. You can slide through those layers. And one of those layers is actually known as graphene. Okay, the whole structure is called graphite with all the layers inside attached. So many graphene structures stack together to form a graphite, but just one layer of that inside the graphite structure is called graphene. And that's in case you don't know what it is. Okay, so which of the following is correct about the physical properties of graphene? Let's say, is it impermeable? Is it hard but brittle? Is it an electrical insulator? Is it a heat insulator? Okay, now you can see here, it is not an electrical insulator because graphite is something that can conduct electricity. Look at the carbon, you can see that the carbon itself is bonded to another 3 carbon atom. So we all know to a certain extent that there will be delocalized electrons throughout the whole structure. So it can conduct electricity. So definitely not C lah. All right. Is it impermeable? To a certain extent, impermeable means it cannot allow certain things to go through lah. Okay. But I think the best answer for this particular usage of graphene lah, because now it's more about the usage of graphene, I would say the answer is impermeable. Okay. So impermeable means things cannot go through. So the structure is so compact that it won't allow things to go through. It makes it a very suitable material in nanotechnology, while the rest of it is not really about the usage of graphene. So therefore, 14 is A. 15 which of the following statements are correct about fats and oils? So let's take a look at this. So if you don't know what fats and oils are, they are basically compounds that can be found in plants as well as in animals. Okay, so they are also called as lipids usually. So for number 15 over here, you must identify the characteristics of fats and oils, which are technically true lah. Okay, so I think in this case, let's take a look at number 1. Fats and oils are esters. They are technically formed through esterification. So therefore, number 1 is correct. And then fats and oils are obtained from animal sources only. That's wrong. Usually fats are obtained from animal sources, correct? But plant oils, oils belong to plants usually, right? Got olive oil, palm oil, sunflower oil. All those oil are basically from plant-based. So animal fats and plant oils. So I'll say number 2 is not true lah. Fats exist in solid while oils exist as liquid at room temperature. This is also true. Okay, usually fats like butter that is in the form of solid. Okay, or chicken skin and stuff. So solid form is correct. And olive oil, sunflower oil, coconut oil, all the oils usually is in a liquid form at room temperature. So I think this is correct. Unsaturated fats can be converted to saturated fats through process oxidation. This is wrong. The process that can convert unsaturated fats to saturated fats is called hydrogenation instead. Okay, the same one as how your alkenes can undergo a hydrogenation process using nickel and 180 degrees Celsius. So the same process that is called hydrogenation, adding hydrogen inside the unsaturated structure to form saturated ones. So 4 is also wrong. So I guess the best answer here will be 1 and 3, which is B. Number 16, diagram 4 shows a setup of apparatus used to determine the empirical formula of metal oxide. So hydrogen gas here will act as a reducing agent to reduce the metal oxide to just pure metal. So which of the following metal oxides is suitable to be used in an experiment? So I think, right, if we check this, right, you must refer to the reactivity series. So the reactivity series in this sequence. All right. So hydrogen is usually located in between lead and copper. So whatever that's above hydrogen, you cannot use hydrogen to reduce the particular substance. Only whatever that's below hydrogen in this series is able to reduce the particular metal oxide to just pure metals. So among the list that you have in A, B, C, D, you'll notice that aluminum oxide is not possible. Silver oxide is possible because silver is technically lower, all right, lower than hydrogen. Iron is above hydrogen, so cannot. Magnesium is above hydrogen, so cannot. So the only possible answer here will be silver oxide. Okay, so the answer is silver oxide, B. 17, table 1 shows the Proton number of two elements, which is X and Y. X has Proton number 2, and Y has Proton number 18. So which of the following statement is correct about X and Y? So can we say, now let's take a look at the atomic structure. So we can actually imagine how the atomic structure looks like by writing down the electron configuration. So proton number is equivalent to number of electrons also in a neutral atom. So I'll say that if X has 2 protons, it should have also 2 electrons, and Y has 18 protons, it should have 18 electrons as well. So to draw the electron arrangement of X, it will be just 2. All right, in this case, it should be referring to helium. And Y will be 288, which is referring to helium, neon, argon, okay? So supposedly this is helium, and this is argon. So you have to determine what is the characteristics of these noble gases. Atomic size of Y is smaller than X. No, it's terbalik, yeah? So this is wrong. Definitely Y will be larger than X because it has more electron shells. Melting point of Y is higher than X. Yes, this is correct. Because the atomic size larger means the attractive forces between the atoms will be stronger. So I think most likely the answer is B, but let's take a look at C and D. Force of attraction between atoms X are stronger than Y. This is not true because the size of X is smaller, so it's supposed to be weaker than Y. So therefore, this is wrong. Number of shells filled with electrons of atom X is more than Y. Also wrong. We can see that there are 3 shells in Y, but only 1 shell in X. So therefore, the best answer here is still B. Always remember that the size of the atoms matter. Okay, in a molecule or in a non-metal, right? If you have a larger size, then the attractive forces between the particles will be increased because of the van der Waals forces. 18. Diagram 5 shows the apparatus to set up to study the reactivity of alkaline metals towards oxygen. Okay, so we have lithium, sodium, potassium usually. They can react with this oxygen. Table 2 shows the observation for the reaction. So X here's observation would be burns with a vigorous reaction with a lilac flame. So lilac is already an indication that X is supposed to be potassium. All right. And then Y here says burns slowly with red flame. So I think most likely this is lithium already. Has a lowest reactivity. And then Z burns vigorously with yellow flame. Then Z must most likely be sodium. Okay. So red flame is an indication of lithium. Yellow flame is an indication of sodium. So what's the correct arrangement of the reactivity of elements towards oxygen in descending order? Descending order means from the highest to the lowest, okay, in terms of reactivity. We know that going down group 1, in the group 1 elements, right, the metals have a higher and higher reactivity, which means the reactivity of the elements increases down the group. So I would say that the most reactive will definitely be X because it's potassium, lowest among the 3 metals that you see over there. So X will be the highest, followed by Z, which is sodium, the second one, and then Y lastly with which is lithium. So the answer will be X, Z, and Y. The answer should be boy. 19. Table 3 shows the electron arrangement of element P and L. So we have element P, which has the electron arrangement of 2,4, and element L is 2,6. So what is the chemical formula of the type of bond that's formed from the reaction between P and L? So L is supposed to be L2 minus. Why? Because it's supposed to be located in group 16, right? So if it's group 16, means it should have a charge of 2 minus. And P is supposed to be in group 14, which is most likely referring to carbon. So if L is going to be 2 minus, then P must act as technically a +4. Okay, because usually it is a +-4, but in this case, because one is only minus, the other must be plus. It's just a theoretical value. So in this case here, P and L together, you can actually do the crossing method. For every P, 1 P, you need 2 times the L. All right. So usually what we do is that if you want to do the crossing method, P4 plus P4 plus and also L2 minus. So this is a +4 and it's -2. We're going to cut off and make it simplified. Then 2 is given to L and P is given to, 1 is given to P. So the formula is supposed to be P L2. So that's the formula. So this 2 is out. And since supposedly group 14 element and group 16 element, they are both non-metals. So in this case, they should be a covalent compound instead of ionic lah. So therefore, the answer here is supposed to be C, because once more, because P is a non-metal, L is also a non-metal, so they are technically non-metal plus non-metal, which then becomes a covalent substance. 20. Diagram 6 shows the Danish flipping a page of book by a wet finger. All right. So which of the following statements explains the situation? So I was referring to hydrogen bonding, right? You can see here, this is actually hydrogen bond. So a hydrogen bond, they are very strong in the sense that they attract to each other very well. As in like the water molecules, they have very high cohesive properties because of this hydrogen bonding. So when you use a wet finger to turn a page, what happens is that there is a possibility where the hydrogen bond will form between the book page with your fingers. So that could be an easy way to flip the pages lah. All right. So if you look at all the answers over here, I think the best answer that describes number 20 will definitely be boil. Okay. Why? You see, boil here says water molecules at the fingertip forms hydrogen bond with cellulose molecules in the paper. So that is the best answer to describe why. Because I already explained to you, it must be hydrogen bonding between the H and the O. Hydrogen bond can form between a few different atoms, H to F, H to O, and H to N. All right. Only this combination can form hydrogen bonding, as in like any molecules that have H to F and then H to O or H to N, they can form hydrogen bonding. 21. Compound Y consists of oppositely charged particles. Which of the following is not true about the properties of compound Y? So if they're referring to compound Y having oppositely charged particles, they're actually referring to ionic compound, which consists of ions, right? Do they have high melting and boiling points? They do, right? Ionic compounds have high melting and boiling point. Do they exist as liquid at room temperature? No, they usually exist as solid. Are they soluble in water? I mean, naturally, they are. Most ionic compounds are soluble in water. Can they conduct electricity in solid state? Solid state cannot, because the ions cannot move. If the ions cannot move, they cannot conduct electricity. So the best answer to describe the properties of ionic compound will be 1 and 3. The answer is boil. 22. Table 4 shows the observation when blue litmus paper is dipped in 3 substances. Glacial ethanoic acid, no change. Glacial ethanoic acid plus propanol, no change. Glacial ethanoic acid, glacial ethanoic acid plus water. Blue litmus paper turns red. Okay. So this is most probably referring to the properties of water to create an effect where acid and alkaline substances can display their properties. So which of the following statement explains the observation? Acids only show the property when dissolved in water. I think that's true. The rest of it doesn't make sense. So therefore, A is the answer. Okay. Alkaline substances and acids can only show their properties in the presence of a certain ion. So for acids, they must be able to produce hydrogen ions. And then for the alkaline substances, they must be able to produce hydroxide ions, right? So the reason why the first one cannot is because the word glacial ethanoic acid means is pure ethanoic acid without water. So there's no water means it won't be able to produce hydrogen ions. So no hydrogen ions means no change. If you dissolve glacial ethanoic acid in propanol, propanol is supposed to be an organic solvent. Okay, this is supposed to be an organic solvent. So if it's an organic solvent, when you dissolve the acid inside, they will not be able to produce hydrogen ions as well. only when ethanoic acid dissolves in water, you'll be able to produce hydrogen ions. That's why after that, you can see the blue litmus paper will turn red. So acidic properties can only be shown when an acid is dissolved in water and then dissociate to release hydrogen ions. 23, table 5 shows the information of two different solutions. So we have hydrochloric acid of 1.0 and carbonic acid also concentration of 1.0. Which of the following is not true about two solutions? Degree of ionization of carbonic acid is lower than hydrochloric acid. This is true. Because carbonic acid apparently is a type of weak acid. All right, but hydrochloric acid is supposed to be a strong acid. So we all know that weak acids don't dissociate completely in water, but strong acids do. So that's the answer. pH value of hydrochloric acid is higher than carbonic acid. This is wrong. It's supposed to be lower, not higher, because we know that the lower the pH value, the more acidic it is, and the more hydrogen ions it has. pH value is measured in the formula where we use this formula. pH is negative log concentration of hydrogen ions, which tells you that the higher the amount of hydrogen ions, the lower the pH value is. And that tells you that technically speaking, HCl is supposed to have a higher amount of H plus when it's dissolved in water compared to carbonic acid. So therefore, this is wrong. C, a big portion of carbonic acid exists as molecules. I wouldn't say it's a big portion, but yeah, you can actually say that it has a lot of carbonic acid that does not dissociate. So this is actually true. And then the concentration of hydrogen ion is high in hydrochloric acid. This is also true. Should I explain to you this now, right? Because it dissociates completely, it should have a higher H plus concentration compared to carbonic acid. So it's asking you which one is not true. So therefore B lah. B is the one that's not true. So that's the answer for number 23. 24. Diagram 7 shows the apparatus step to prepare silver chloride. So silver chloride is supposed to be an insoluble salt. So to produce that, you have to use a double decomposition method. So which of the following materials is most suitable to use to react with hydrochloric acid to prepare silver chloride? So you're actually using hydrochloric acid, which contains H plus and Cl minus already lah. So it must be something that can dissolve in water. Silver metal cannot dissolve in water, so cannot. Silver carbonate also cannot. Silver sulfate also cannot. So the only possible answer here is silver nitrate. Remember that all nitrates are actually soluble. Okay, so it doesn't matter what nitrate, all nitrates are soluble. So you can use silver nitrate here to perform double decomposition with hydrochloric acid to produce silver chloride. So the equation is very simple. The equation is AgNO3 plus HCl. You'll be able to get AgCl plus HNO3, sorry. Got confused for a while. So that's the answer. You get nitric acid at the end. Done. Jessica went to see Dr. Ahmad because she had the gastric. The MA shows the conversation between Dr. Ahmad and Jessica. So yes, she said the antacid tablets are used to treat gastritis and that you're experiencing. Chew this tablet before swallowing. And then after that, the girl says, Jessica says that, yes, Dr. Ahmad, I will follow the doctor's instructions. I mean, technically, I will follow your instruction. Thank you. So I think it's referring to the effects of antacid tablets. So why does Dr. Ahmad give this instruction to Jessica? So he says here, it can treat gastritis. All right. And you can chew this tablet before swallowing. So if you are talking about treating gastritis, means that the antacid tablets can react with acid, because if you have gastric attack or gastritis, means you have overproduction of acid in your stomach. So by eating the antacid tablet, it can neutralize the acidity of your stomach. I think it's referring to chew this tablet before swallowing. So chew the tablet before swallowing is actually to increase the surface area. Okay, right? Again, chew this tablet before swallowing. Why must chew it? Why can't just actually just drink it? I'm sorry, just throw it into your mouth and then just swallow it. I think the reason why is because we want to make sure that there is enough surface area to react with the acid. So if you were to technically chew the tablet before swallowing, it will increase the surface area of the antacid tablet, which can then react with the acid more efficiently. So I think that's what the doctor is trying to say. And the best answer here is to, I think all doesn't make sense of a C, to break up the tablet into smaller pieces so that we can sampler pieces. It's just a typo, it's supposed to be smaller. Break up tablet into sampler pieces. Okay, smaller pieces, that's the idea. Okay, that does increase the surface area to react with the acid. The rest of it doesn't make sense, right? It doesn't, you shouldn't increase your concentration of the stomach acid, then the person will just die. To make it easier for patients to swallow tablets, I don't think an adult needs that kind of advice. To reduce the total surface area, that's actually wrong. We want to increase the surface area to increase the rate of reaction. So yeah, C is the best answer. So once again, the logic is to increase surface area, increase total surface area to increase the, to facilitate the reaction to move on faster, to increase the rate of reaction. 26, the student carried on an experiment to investigate the hardness of an alloy with the pure metal. Diagram 9 shows the diameter of the dents produced in an experiment for substance P and Q. So the larger the dent means the stronger the material. Okay, so which of the following statement is correct about P and Q? So again, one more time, diameter of the dents produced, you can see here, diameter of the dents produced. The larger the dent produced, then the weaker the substance. So I would say that this is supposed to be technically a pure metal. And the one that has a smaller dent will be an alloy. Okay, because alloys are technically harder and stronger. So substance P is resistant to corrosion. This is wrong. Pure metals are quite susceptible towards corrosion, so that's not correct. Atom of Q is arranged in an orderly manner, also wrong. Alloys have no regular arrangement of particles because the foreign particles will disrupt the regular pattern. That's why they can't slide easily. P is made of one type of atom of the same size. This is correct. Pure metals have the same atoms. The layers of atoms in Q is difficult to slide over each other when force is applied. This is also true. Alloys have no regular arrangement, so that's technically correct. Therefore, the answer here will be number 3 and number 4. C. 27, table 6 shows standard electrode potentials values of half cell for some metals. Okay, so we have magnesium, zinc, and copper, all right, which are different E0 values. So which of the following is the arrangement of atoms or ions in an ascending order of the strength of reducing agent? I would say the reducing agents are substances that undergoes oxidation process. Do you remember that? Some of the students get very confused of what this means. So reducing agent refers to a substance that undergo oxidation process. So if they're asking you the arrangement of the strength of reducing agents in ascending order, is referring to the one that can be oxidized the least easiest. Wait, that's very confusing. How about this? Before the E0 value, it's easier. Okay, so the more negative the value of the E0, right? So it's E0. The more negative the value is, the better it is as a reducing agent. So I'll put here, more negative E0 value equals to better reducing agent, because it is more easily oxidized. So in this case, magnesium is the most negative. So magnesium is technically the best reducing agent. So we'll put here as the best reducing agent. So which means the worst will technically be copper because it's most positives in it. So since they want ascending order, the weakest to the strongest will be copper, followed by zinc, followed by magnesium. So therefore, the answer here will be donkey. We're referring to the metals, sorry. So you can see there's two variation here, right? There's either B or D. Either you should choose the ions or the atoms to act as a reducing agent. Usually, you want the substance to be able to be oxidized. A better reducing agent means it can be easily oxidized. So the ions cannot oxidize easily because they are already ions. They are already oxidized. You understand? Right? So D is not the answer. D cannot be because they are all oxidized already. In order for them to undergo oxidation, they must lose electrons. But in the D, all the ions already lost electrons already. So how are you going to lose more electrons? It doesn't make sense, right? So B is when before it loses electrons. So it wants to be more stable, to achieve octet technically. So I would say that atoms of copper, zinc, and magnesium, they can release electrons to be oxidized, and therefore only then they can act as a reducing agent. So B is the answer, not donkey. 28, diagram 10 shows the structural formula of an organic compound. So there's a carbon-carbon double bond here, which indicates that it is supposed to be an unsaturated compound. And they're asking you to name the organic compound. The first step of naming an organic compound is to determine the longest continuous carbon chain. So longest continuous carbon chain is like this law, all right? There's no branch technically. The branch over there is just to confuse you. This is not a branch. This is already connected in a sequence. So you do not have to name it as a methyl group. So since it's a continuous chain, 5 carbon atoms, we start numbering carbon atoms from the one that's closest to the functional group. And the functional group here is the carbon-carbon double bond, which tells you that carbon number 1 is over here, not over here. So then we'll start with here, 1, 2, 3, 4, and 5. So now the double bond is located in carbon number 2. So therefore, it must be a pent 2-ene. Why pent? Because got 5 carbon atoms, pent law, all right? And it's also a double bond, carbon double bond, which indicates that it is actually an alkene. So therefore, it must be pent 2-ene. So the answer here will be A. Either pent 2-ene or 2-pentene. Both also okay. So that's the answer for number 28, A. 29, diagram 11 shows the materials used to remove oily stains from a piece of cloth. One is hard water plus soap, and the other one is acidic water plus soap, soft water plus detergent, acidic water plus detergent. So I'm not sure which is which. Let's see what the question says. Which treatment can remove oily stain? Okay, now let's see. So if we have hard water plus soap, it doesn't work because soap doesn't work in hard water. Hard water is the one that contains magnesium and calcium ions, which can form scums with soap. So A doesn't work. If you use acidic water plus soap, it depends on what acid it is. I don't think there's anything wrong with acidic water. Soft water plus detergent definitely can. Okay. I think in all cases, detergent works technically somewhat the best in a way. So I think this is the only one that can work, because usually soap doesn't work efficiently with hard water or any other water. Usually just soft water is the best for soap. In this case, then I would say for detergent, right, because they're able to work much more efficiently in different types of water. So definitely 3 and 4 is the answer. So therefore, the answer here will be cat. Number 30, diagram 12 shows the injury of a student during sports day. What's the type of medication should be used or taken by the student? So I think the person scraped the skin, so it has already damaged the first layer of defense. So most likely it needs to use an antiseptic to clean the wound. But it says here taken. Taken means, I think, you have to eat it. So I don't think you should eat analgesic unless you feel painful. So analgesic is actually a type of painkiller. It reduces the painful sensation. Antimicrobials is actually used to, for example, antibiotic can be used to kill germs. But I don't see any pus coming out from the wound, so I'm not. Most likely, it is not antimicrobial. Corticosteroids is steroid medications, which is normally used maybe for allergic reactions and things like that. So C is definitely not as well, and definitely not D. No person in their right mind will eat psychotic drugs when they script themselves, right? I mean, like, can you imagine, like, oh, I fell down. Oh, okay, let's eat some antipsychosis. Doesn't make sense. So that's definitely wrong. Now there's a choice between analgesic and antimicrobial. I mean, you may get some infection there if you leave it for too long. But if you think about it, the person just fell down. So I think pain comes first, then infection. So it's most likely analgesic first, okay? Antimicrobial will be more important when you get the infection later on. That's when you get fever and you get some weird sensation in your body. Yeah, but I think for now, because it's very painful, the person should take analgesic first. So therefore, the answer is A. 31, the following equation represents the decomposition reaction of solid copper to nitrate. So it shows you here 2Cu-NO3 breaks down to form 2 copper oxides, 4 moles of nitrogen dioxide, and 1 mole oxygen. So what's the volume of oxygen gas produced at room condition when 1.88 grams of solid copper to nitrate is decomposed? Okay, so let's calculate the MR of CuNO3. So this is actually 2:1 ratio. So MR of CuNO3 will be 64 plus 2 times 14 plus 6 times 16. (188) is the MR. So right now, to calculate the number of mole of CuNO3 will be 1.88 grams divided by 188 grams per mole. So it's the molar mass. So you should be able to get 0.01 mole. So if you compare number of mole, every 2 moles of copper nitrate will give you 1 mole of oxygen. So therefore, we will say that the number of mole of O2 will be half long. Okay, so 0.01 divided by 2, we should get 0.005, if I'm not mistaken. Yep, 0.005. It's not like a number of mole, you can then calculate the volume of gas produced at room condition. So that will be technically 0.005. Okay, wait, so volume of gas will be number of mole multiplied by molar volume. So in this case, it will be 0.005 multiplied by 24 decimeter cube. Should be able to get 0.12 decimeter cube, right? But since the answer wants it in cm cube, we have to multiply by 1,000. So 0.12 times 1,000 will technically be 120 centimeter cubes of gas. Therefore, the answer here should be C. Right, let's move on. Next one, 32. When copper 2 carbonate is heated, lime water turns cloudy and black solids form. Which of the following equations represents the reaction correctly? So copper 2 carbonate decomposes to form copper oxide. Copper oxide is black in color, and then it releases carbon dioxide gas. So I think the only possible answer that's correct over here is CuCO3 breaks down to form CuO plus CO2. So the answer here will be supposed to be boy. 33, in which of the following test tubes does a reaction occur? Glacial ethanoic acid, solid calcium carbonate cannot. Because glacial means it's not dissolved in water. So if there's no water, it means an acidic substance cannot show its acidic properties. So therefore, A is out. Glacial ethanoic acid litmus paper doesn't work also because there's no acidic properties. Glacial ethanoic acid with potassium carbonate solution, can it work? Yes. But you must be wondering, like, is glacial? Does it have water? Yeah, but potassium carbonate solution has water, ma. So when it's dissolved inside the water, it will dissociate first before it reacts with the potassium carbonate. So yeah, it still works because there's water inside potassium carbonate. Well, the rest of it has no water, right? Magnesium also no water. So putting inside glacial ethanoic acid will not work as well because all A, B, and donkey, the three situations, there's no water at all except for C. Potassium carbonate solution has water inside. Okay, so therefore C is the answer. 34. 14.9 grams of potassium chloride is dissolved in distilled water to produce 0.4 mole per dm cube of potassium chloride solution. What's the volume of distilled water needed to dissolve potassium chloride? Okay. So right now we need to check and see. So in this case, molarity, the formula, the core formula over here is molarity is equivalent to number of mole of the substance divide by the volume in decimeter cube. Okay, so right now, to get the volume of water needed, we have to check and see what is the number of mole of potassium chloride. Okay, so right now our molarity is this much. Okay, our mass of potassium chloride is this much. So let's get the number of mole of potassium chloride. So number of mole of KCl will be 14.9 divided by 74.5, which is already given. So 14.9 divided by 74.5 will give you 0.2 moles. So right now we need volume. So volume is equivalent to number of mole divided by molarity. So that will be 0.2 divided by 0.4. So that'll be 0.5 dm cube, which is equivalent to 500 cm cube. So the answer for number 34 is C. Just use the formula. The formula will help you a lot. So the only problem here is that if you cannot solve this particular question, it means that you're not very good with the mole concept yet. And you need to look back into your chapter 3, form 4, and also chapter 6, form 4 as well. Okay, acid, bases, and salts, where you also learn about molarity, concentration. So the core formulas there, you must memorize it. If not, you won't be able to get the answer. So work on that. 35, table 7 shows the total volume of hydrogen gas collected at regular intervals for reaction between zinc and dilute hydrochloric acid. So we have different volumes over there. What's the average rate of reaction? So average rate of reaction will be total time taken, total volume of gas collected over time taken. So the reaction technically stops over here because you see after that it's the same already, right? So the reaction, the time taken is actually 2.5 minutes to complete. So total volume of gas divided by total time taken will be this one. So rate will be 26.5 cm cube divide by 2.5 minutes. That will give you 10.6. cm cube per minute. So the answer will be C. 36. Then 13 shows the apparatus to set up the investigation to the reaction between potassium iodide and iron 2 sulfate solution. So which of the statement is correct about the reaction? So what is going on over here is very simple. This one over here is the oxidizing agent. Because we all know that acidified potassium manganate 7 is a very good oxidizing agent. And now this one becomes the reducing agent. Which also tells you that this particular substance over here that is responsible will be undergoing oxidation process, while this one will undergo a reduction process. Sorry. So let me just give you the half equation for both sides. For the first part over here will be MnO4 minus accepting 5 electrons. Also after that, accepting H plus H plus to give you Mn2 plus 4H2O. Okay, so this is how it undergoes the reduction process. And then on the right side, what happens is that iodide itself will be oxidized by releasing electrons to form molecular iodine. So these are the equations that you'll be able to see. So what happens is that the solution will turn from purple to colorless because potassium manganate 7 is purple, right? After it is reduced already, it becomes colorless because it's Mn2 plus. And then the iodine is supposed to be colorless. Iodide is supposed to be colorless. And then iodine turns brown. So that's why you'll be able to see on both sides of the area. So manganate 7 ions oxidized to manganate 2, wrong. 7 reduced to 2, not oxidized. So therefore, the word oxidized here is not suitable, that's wrong. Color of potassium iodide changes from green to yellow. I don't see any, potassium iodide changes from green to yellow. No, it's wrong. It changes from colorless to brown. So potassium iodide itself is colorless. After that, it turns into brown. So wrong also. Iodide is oxidized to iodine. That is correct. It releases electrons, right? So when it releases electrons and it gains in oxidation number, so it is supposed to be oxidized. Potassium iodide is an oxidizing agent. This is wrong. I said that it is supposed to be a reducing agent because the other side is already an oxidizing agent. So right side must be reducing agent. So the best answer here will be cat. 37, diagram 14 shows a chemical cell. The electrons move from electrode L to electrode M through the external circuit. This is called a Daniell cell, actually. So there's a porous pot that separates the two solutions from each other. One has M2 plus and one has L2 plus. Which statement is correct about the reaction in chemical cell? M2 plus is oxidized. Wrong. M is oxidized. What happens here will be, L is the one that oxidized. So you see electron flows from the right to the left in this direction. So that tells you that L is more electron positive, or should I say more reactive like in this case. So L will be the one that dissolves to form L2 plus and releases the electrons. So electron will travel through the external circuit and then it will come down back down to M. So L is the one that undergoes oxidation process, not M2 plus, so wrong. Reduction occurs at L. Like I said, it's supposed to undergo oxidation, so it's wrong. E naught of L is more negative than M, correct. The more negative the E naught value, the better it is as a reducing agent. And therefore, the easier it is to be oxidized. So C is technically correct. Positive terminal is L, wrong. The more electropositive substance, or should I say, the better reducing agent becomes the negative terminal, not positive. So therefore, this is wrong. So the answer here will be C. 38, which of the following is R isomers of C4H9OH? So you can draw one by one. So propan 2-ol will be something like this. I'm going to draw a very small one because it's going to take up space. So propanol, this is not this. Okay, first of all, this is C4. You know what? Not to draw, so never mind. You can just write the formula straight away, isn't it? So this is C4. Propan 2-ol will be C3. I think most of you would like me to draw anyway. I'll use a simplified structure then. So that would be CH2. So as you can see over here, there are technically 3 carbon atoms only, so this cannot be the answer. Butane 1-ol. So butane 1-ol will be okay, butane 1-ol. So you calculate the number of hydrogen and number of hydrogen and number of carbon, number of oxygen. You should know that this is actually correct for number 38, right? And then 2-methyl propanol, propan 2-ol, 2-methyl propan 2-ol. So 2-methyl propan 2-ol will be so this will be CH3 and OH. So 2-methyl propan 2-ol. Calculate the number of carbon atoms and number of hydrogen atoms and oxygen. You should also get this is correct. 2-methyl butane 2-ol. Okay, now 2-methyl already got 1 carbon. Butane also got like 4 carbons. So total got 5 carbon atoms already. So definitely not the answer also lah. Because on the C4 only, right? This is like technically 5 carbon atoms. But if you want me to draw, also can lah. So butane 2-ol will be 2-methyl butane 2-ol. Methyl butane 2-ol will be like that. So you can see that there are 5 carbon atoms in total. 1, 2, 3, 4, 5. So cannot be lah, because we only can see there's only 4 carbon atoms in the formula original. So the only answer that's possible will be 2 and 3. The answer will be donkey. If you are in doubt, you don't know how to write the formula out, you can actually always just draw the structure. If you want a general formula of alcohol, is basically CnH2n plus 1 OH. So by using the formula, you can also tell and see what is the number of carbon atoms, number of hydrogen atoms, and so on. 39. The following information shows the results of an experiment to determine the heat of combustion of fuel X. So what is the heat of combustion of fuel X? So we have a mass of fuel burn is 18 grams, volume of water is 250, and increase in temperature is 16 cm. So you must use 2 formula over here. The first one is Q is equivalent to MC theta. Second one will be delta H is equivalent to Q over N. Okay, so let's do the first one. The first one is Q is equivalent to MC theta. Mass refers to the mass of water. So if it's a 1 gram per cm cube of density, means for every 1 cm cube is 1 gram. So the mass here will be 250 multiplied by 4.2, which is the constant that's given to you. And theta will be a change in temperature, which is 16. So that'll be a total of 16,800 joules, which can then be simplified into 16.8 kilojoules. Okay, and then after that, your N, which is your number of mole, will be depending on the mass of fuel burn. So you have to check and see what's the molar mass of fuel X. Molar mass of fuel X will be 180 grams per mole. So N will be number of mole. N is equivalent to mass divided by molar mass. So it will be 18 divided by 180. That will give you 0.1 mole. Okay. So then after that, you can use the second formula over here, which is delta H is equivalent to Q over N, which is now 16.8 kilojoules divided by 0.1 mole, which will give you a negative 168 kilojoules per mole. Okay, now this is your answer. Therefore, the answer here will be C. Okay, negative 168 kilojoules per mole. Okay, number 40, the equation below represents a neutralization reaction between nitric acid and barium hydroxide to get barium nitrate and water. Says here 10 cm cube of 0.1 mole per dm cube of barium hydroxide solution is titrated with 0.1 mole per dm cube of nitric acid. So what happens here is that you're using 10 cm cube or 0.1 mole per dm cube of barium hydroxide titrated against 0.1 mole per dm cube of nitric acid. But if you notice, right, for every 2 mole of acid, you need 1 mole of barium hydroxide. So which means you need twice. If you're using the same concentration, then you will need twice the volume of nitric acid. So which means the volume required for nitric acid will be 20 cm cube. So it says here the initial reading of the burette is 20 cm cube. What's the final reading of the burette? So how the burette works is very weird. As it goes lower and lower, as in the volume, right? You put the liquid inside the burette. As it goes lower and lower, the number will technically increase. So since initial reading is 20, right? And you also use up 20 of it. So as you go lower and lower, then you'll be able to get the number higher and higher. So to get the final reading of the burette, it is actually 20 plus another 20, which is a total of 40 cm cube. And that's how it works. The burette is a bit weird in the sense that the scale goes in the opposite direction. So therefore, it's 40. The answer is C. So that is all for this particular paper. So I hope you guys have learned something in this particular discussion, as well as to prepare yourself for your exam. So I think that's all from me for this particular paper. I'll see you guys in the next video.